To operate our system, we need to connect the hardware connection. Our hardware connection will be consisted of air pump, valve, buzzer, 3 batteries, battery holder, a breadboard, and Arduino, and temperature sensor. For connecting the valve, we will need TIB122 transistor and diode and 1K resistor. So we will take a wire from pin 3 on Arduino to the 1K resistor, and then the other side of 1K resistor, it will go to the base side of the transistor. The collector side of transistor will go to the diode, which is over here, and then this side of diode will go to the valve, and the other side also it will go to the valve, and the red wire over here, it will go to the power supply, which is 12 volt, and the emitter of the transistor, which is over here, it will go to the ground of the power supply. Same thing for the air pump, but we will take a wire from pin 4, so we can control it from pin 4. But same way of connection, we will use transistor and diode and 1K resistor. For connecting the buzzer, we will take a wire from pin 9, which is over here, to the red side of buzzer, and this wire will go to the ground. Place the FSR sensor over here on the cuff, because the main pressure will be applied from this side. There are 2 wires for FSR sensor. One wire will go to 5 volt, which is this one. The other one, which is this wire, will go to 10K resistor. We place the 10K resistor on the breadboard. It's over here. And the other wire, which is the orange one, will go to Arduino, the pin A0. So pin A0 will be for FSR sensor. And the other side of the 10K resistor, there is wire will be connected to the ground. For Bluetooth modulo, we used 4 pins. VCC will go to 5 volts, which is there, and the ground on a Bluetooth modulo will go to ground, which is this side, and the TX and the Bluetooth modulo will go to RX on Arduino, which is here, and the RX on Arduino will be connected to 2 resistors. The resistors here, they are one of them 2.2K and the other one 1K. The TX on Arduino will be connected to here. It comes from Arduino TX from here, and the ground will be connected in this side of resistor, exactly here, this side. We bought 2 resistors for a Bluetooth modulo to convert the power from 5 volt to 3.3 volt. It's working like a voltage divider, so it will protect the Bluetooth modulo from damage. The temperature sensor, we connect 3 pins. VCC to 5 volt over here, and ground to ground, this side to ground over here, and the out to pin 2 on Arduino, which is over here. Here we connect the power supply 12 volt to the positive side to switch, and then it will be connected to breadboard, this side, the positive side, and the ground side will be connected directly to the negative side of the power supply over here. To read the power voltage from the power supply, we need to connect the power supply to Arduino. So to connect the power supply to Arduino, we need two resistors. One of them is 6.8 kilo ohm and the other one 10k. So we connect the positive side of the power supply to this side and the negative side, which is the ground, to this side, and we connect this wire over here to pin A1 on Arduino, which is over here. When we connect the power supply to Arduino, we need to use two resistors to protect the Arduino from damaging. The reason is we converted the power from 12 volt to 5 volt. Code for Arduino. First of all, we define the necessary libraries. The first library we import is the DHT.h. It's for temperature sensor. Then we define the states, which are idle, increase, decrease, servo, continuous, off. And then we set the initial state, which is idle. After this, we set the pins. For pin 9 will be for buzzer, and pin 2 will be for temperature sensor, pin 3 will be for motor, and pin 4 for valve, A0 for FSR sensor, A1 for reading the voltage. Also, we define the variables we're going to use in our code, like temperature, FSR reading, wanted pressure, voltage, and current voltage. Here we set the inputs and outputs. In our code we have 3 output, buzzer, valve, and motor, and 2 input, FSR sensor reading a voltage. Then we define the function we're going to use. The first function is get voltage. It will be used to get the voltage from the battery, from the power supply. And the second function is get the pressure. It will be used to get the pressure from the FSR sensor. In the loop, first of all, we define the data that will be received from the application, and then we read the temperature from the temperature sensor. The first case here is the idle. We set everything to low, all the outputs. Then we read the pressure. If the pressure is more than 980, the buzzer will be on. Also, if the temperature more than 50, the buzzer will be on and it will go to off state. Then it will read the voltage. If voltage less than 940, which means the battery is low, so the buzzer will be on. Here it will check the data received from the application. The data will be a letter. If the received letter is A, it will go to increase state. If B, it will go to idle. For C, it will go to decrease. For D, it will go to idle, and for S, it will go to servo, and O for continuous. But before go to continuous state, it will read the wanted pressure, so the current pressure. For F, it will go to off state. For increase state, the motor will be on and the rest of part will be off. And it will do same thing. It will read the pressure. If it's more than 980, it will do same thing. The buzzer will be on, and same thing for temperature and voltage and data received from the application. For servo, the motor will be on, and then will be delay for 5 seconds, and then the valve will work and delay for 2 seconds. It will keep doing same thing at the servo, so it will be like a massaging. And then it will read the pressure, as we mentioned before, temperature, and the current voltage to alert the user in case of battery low, or the temperature is high, or the buzzer, or the pressure is more than 980. So it's for safety purpose. And continuous mode, it will read the values of FSR sensor. If the reading in the range, so not the difference is not less than 30, everything will be off. So it will keep same pressure. If the pressure go down, the motor will be high. So the difference should be more than 30. If the pressure go high and the difference more than 30, the valve will be working. Otherwise, everything will be off. And then it will check the pressure, temperature, and the voltage, as we mentioned before, for alerting the user in case of any problems. In off state, the valve will work for 5 seconds to empty the air, and then it will go to idle state. At the decrease, the valve will be working. Step, we need to open Android Studio. The version is 3.5. We open an existing Android Studio project. Then we choose our application, which is CVI. We click here open and waiting for preparing workplace. Sometimes when our application is opened at Android Studio 3.5, we have two main files here. One for XML, how our application look like and the buttons, so the layouts, and one for Java code. And to operate the application, we need to download it to the phone. So there are many ways to download the application. The simplest way is to build APK. So it will create a file that we can take it directly to the phone, and then we can use it directly. So here is the file we created. We need this file. We will take this file to the phone. Here is the application after we download it from the laptop, and also we upload the code to the Arduino. Now we put the battery on the charger. When the lights became green, it means the batteries are fully charged and we can use them in our system. We switch the system on, and then we go to the mobile phone to turn the Bluetooth on. And now we select the Bluetooth module and waiting for pairing. We insert the password, which is 1234. Now they are paired. Then we go to the application, CVI application. We made it by an Android Studio. We click here connect. The text view shows us the connection status. The connection is open now. So we will make a short test for increase and decrease button. When we click increase, the air pump work. When we click decrease, the valve will work. Later on, we will test the rest of the buttons when I apply the cuff. I apply the cuff on my legs. When I click increase, the air pump will work and the pressure will increase in the cuff. When I click decrease, the valve is work. When I click servo mode, the pressure will increase and then will decrease. It will continue doing like this. This is the servo mode. Continuous mode. The system will keep the same pressure on the cuff. So if the pressure on the cuff became low or less than the required one, the air pump will work. If the air in the cuff goes up, the valve will work. When I click off, the valve will empty the air from the cuff and then it will go to off state. When I click disconnect, the connection is closed. When the pressure going over the safety range, the buzzer will be working. So we will test it now. Now the buzzer is working. Also, in case of low battery, the system will alert the user by the buzzer. To test low battery case, we will apply 5 volt from the laptop to the Arduino. And now, as we see here, the buzzer is working. The temperature sensor will protect the system from damage. So when the temperature became very high, it will switch the system off to protect the system.